Today, we're digging into LiveStore's beta. LiveStore is a TypeScript state management library that uses event sourcing. When using LiveStore, we start by defining events. Whenever we emit one of these events, it's passed to a corresponding handler called a materializer. Materializers are simple functions that perform mutations to our database. LiveStore is currently geared towards SQLite, so you can use LiveStore in Node and web browsers. And for browser applications that use React, LiveStore has a really nice React integration and can entirely replace React context and use state. Going a little bit deeper into the architectural decision of event sourcing. Event sourcing makes it easier to reason about how state is mutated. We can keep the list of events that we commit, and at any point in time, we could replay those events to recreate the current state, as well as any of the states that came before it. This gives us a valuable property, which is time travel. An example of this approach in the wild is Git. We can go and see the state of our code base at the time of any commit. So event sourcing gives us time travel, which is really useful for debugging, auditing, and forking resources. Instead of console logging your way to the cause of an invalid state, you can just see what event came before the invalid state and then fix the corresponding materializer. And in LiveStore, this experience is really smooth. It prescribes a principled API for structuring event sourcing systems. Today, we're going to try it out for the canonical to-dos example. We'll also brush up against a current limitation of LiveStore, which is that the QueryBuilder doesn't yet support building certain expressions, such as those with compound conditions. So we'll actually create an integration for LiveStore that lets us use Drizzle's SQLite QueryBuilder for building queries for LiveStore. This video is broken up into parts. First, we'll configure a TypeScript monorepo to house our LiveStore example and the LiveStore Drizzle integration. This will include my go-to library configuration preferences, just in case you're curious, although of course, skip ahead if you'd like. Next, we'll create a canonical to-dos list example that uses LiveStore. We'll implement our LiveStore Drizzle integration, which will allow us to use the Drizzle query builder with LiveStore. Let's do it. All right, here we go. First thing, we're going to go to whatever directory we want the project in. Now we're going to make our project directory. We'll init git and we'll open it in VS Code. We're going to structure this as a monorepo with two packages. First is going to be the actual LiveStore Drizzle package, and the next is going to be examples. Each of these is going to need a package JSON. The examples package JSON is going to have a name of examples. It is going to be private. It will make use of type module, and we'll install the actual dependencies momentarily. The package JSON of the LiveStore Drizzle will have a name of LiveStore Drizzle, a publish config of access public, an initial version of 0.0.0. We'll add a license of Apache 2.0. We'll tell it the repository information. Type is Git, URL, and the directory will be LiveStore Drizzle. Type module. We'll give it the description. Construct LiveStore queries using Drizzle for query building. And we're going to build the root exports at dist index.js. We'll cd into LiveStore Drizzle and bun I peer LiveStore. And we'll also install as peer Drizzle orm. So we have our two peer dependencies. Next, let's create the root package JSON. This can have a private set to true, a type set to module, and we'll specify our workspaces. Let's open our console, go back to the root directory, and install a few dev dependencies. Types bun, types node, TypeScript, and dprint for formatting. We'll then create a few scripts, build, tscb, and watch, which is the same thing, but with the W flag. Let's go ahead and delete the bunlock and node modules from this child package. We're going to go into the examples and add a dependency wherein LiveStore Drizzle is coming from workspace 1 star. Let's bun I. And now we can configure tsconfig.json. Since this is a mono repo, it's going to be files, empty array, references, and here we're going to add path to LiveStore Drizzle and path to examples. Within each of these, we're going to need to create tsconfigs, but we want them to share some base configuration. So let's, in our root directory, create a tsconfig.base.json. I'm not going to go over all of these right now, but these are in the GitHub repository, which should be linked below. This is a fairly standard and strict TypeScript configuration. Maybe the one thing worth calling out is that I have this new option, rewrite relative import extensions, set to true, and allow importing TS extensions also set to true. So this means that when we import from a local TS file, we're actually going to include the .ts extension. And this has a few benefits, one of which is it will be friendlier for Dino usage. We'll create a tsconfig.json here, and we're going to extend our tsconfig.base. And we'll set the compiler options, no emit equal to false, which will overwrite what we set in the config base. Set the outdir equal to dist, since that's what we reference inside of the package JSON exports. The final line of this configuration is going to include all source files in this directory. Some people like to have their source files under source, but frankly, if all you have is a package JSON and a tsconfig, you might as well flatten it. So we're going to leave it to include all files in this directory. And our examples tsconfig.json will also extend the tsconfig base. It will also include everything in this directory, and it will have a single reference to the LiveStore Drizzle tsconfig, given that the examples are going to utilize this package. Next, let's set up formatting by creating a dprint.json. Within here, we specify the plugins. We configure these 4 plugins, so we want formatting for YAML, Markdown, TypeScript, and JSON, and this includes JSON-C. For our Markdown files, we're going to set the text wrap to always. For TypeScript configuration, I like to set the arrow function parentheses to be forced, so these are non-optional. That means that we won't regularly have to add or remove parentheses as we change an arrow function to and from being unary. Next, we'll add a line width of 120, and we'll have semicolons only used when strictly necessary. I'm going to add a VS Code /settings.json. And in here, we're going to specify formatter for JSON, editor.default formatter is dprint. We do the same thing for JSON-C. If we ruin the indentation and save, we're not yet getting format on save, so let's configure that. And now when we save, we get formatting. Now let's add support for Markdown, editor.default formatter to dprint, TypeScript, editor.default formatter, dprint, and YAML. We'll also set the editor.tab size to 2. And we'll tell it that the dprint path is at node modules/bin/dprint. And this will ensure that we'll just make use of the binary through its NPM distribution. We'll add an editor config with the basics. We'll add a git ignore. This will have tsbuildinfo.dsstore, a very pesky file, anything emitted by the TypeScript compiler, and node modules. Let's configure cspell. Here's the configuration, and we need to make this words.txt file. Let's create a file in examples, a to-dos example, which is kind of like the canonical example for local first applications. Before we do anything here, let's install some dependencies in examples. We'll cd into examples. We'll install LiveStore, the LiveStore node adapter. And that should really do it for now. Now, the first thing that we're going to do in thinking through the to-dos example is think about what events we should be able to emit. Import events from LiveStore. Export const events equals to-do created events.synced. Name will be v1.to-do created. And we want to give it a schema. So up top, let's bring in schema. You could also pull this in directly from effect. This is going to be a struct with an ID, which should be an integer, and the actual to-do text. Next, the ability to mark the to-do as completed. Name is v1.to-do completed. And the schema.struct with the ID schema.int. Let's copy this for the next event. This is going to be uncompleted. So marking a completed to-do as now incomplete and uncompleted. And in a real to-do application, we'd probably want a few more events. For instance, the ability to completely delete the to-do or to clear the entire list of to-dos. We might also want to be able to attach different tags to a given to-do. There are a lot of different directions we could take this, but we just want a very simple example so we can test querying using the Drizzle query builder and the adapter that we're going to build after we set up this example. Maybe one other change we can make before calling it a day with our event types is let's add event times to each of these structs. So up here, date is going to be schema.date. We're going to have the same thing here and here, and that should be good for now. Now that we've mocked out what events are possible, let's figure out the shape of the database into which we're going to materialize those events. So every time that one of these events is emitted, we're going to take it in and update the database accordingly. Export const tables equals to-dos equals state. This comes from LiveStore.SQLite.table. Within here, name equals to-dos. Next, we're going to export const tables. This is going to be a record containing our table definitions. So a to-dos table, we're going to have to bring in state, which is from LiveStore.SQLite.table. And this is going to have a name, in our case, to-dos. It's going to have columns. The ID is going to be an integer. This is going to be our primary key. We need another column for the text. We will default this to an empty string. We need to be able to mark whether it's completed. This is just a Boolean, and the default value would be false. And we'll have a last modified, which is going to be an integer, but we're going to pass in a schema, date from number. And this way we'll be able to interact with the last modified as the date. Right below it, we're going to create a materializers. So SQLite dot and materializers. This takes in the events record. And then we get these type save completions for the arms for handling the different events. Let's just stub these out and we'll throw 0 to satisfy the checker. I kind of want to put this one first. The way that we'll implement this is first by extracting ID text date, and then we're going to return tables.todos.insert. We'll pass in the ID. The initial completed value is going to be false. Text is from the argument. Last modified is going to be equal to date. In to do completed, we're going to extract the ID and the date, and we'll return tables.todos.update completed true where ID. And again, the last modified will be set to date that we receive. Meanwhile, we can take this and reuse it. We need to get the ID and date just like above. And this time we'll set completed equal to false. I exported these up here, but we're going to have this example in one file. So maybe let's get rid of that. And let's create a schema with make schema. This also comes from LiveStore. The first thing we pass in is the events, and then we pass in state. State is made from state.sqlite.makestate. This takes in the tables and our materializers. You may notice we get this blue underline. This is just a C-spell error. So to solve this, let's pull up the quick fix menu and select add materializers to dictionary project words. Once we do that, the words file from before will contain that. If we were to delete it from that words file, we would get this issue again, but let's keep it there. So we've scaffolded the events and kind of the materialized shape and the way that you get from events to the materialized shape, but we haven't yet specified the backend. So let's do that. We'll create an adapter using the make adapter. This is coming from LiveStore/adapter node, but there's also an adapter for browsers and I think for Occupy workers. I'm not certain, but for now, we're going to use the node adapter. Here we can specify the storage mechanism. We're going to use file system store, and we'll set the base directory to be 10. Down here, there's an option for sync. This is configurable. We're not going to use it right now, but this is pretty cool. This is how you actually get that local first state uploaded into some kind of a service that propagates it to other devices that are connected. But we're not going to use this right now. Next, let's create an abort controller. We're going to use this to control the life cycle of the store. So we'll say store equals await create store promise. This is coming from LiveStore. We pass in the adapter. We pass in our schema. We pass in a store ID. In this case, let's call it to-dos. Or actually, since that's a table name, maybe let's say to-dos store. And we're going to give it the signal. So controller.signal. Right below there is where we're going to interact with store. And once the interaction is done, we're going to abort, clean up the resources, and that'll trigger a graceful exit of this process. But here's where the magic's about to happen. Get rid of this and let's commit some events. Events.to created. We'll give it an ID of 0. Text, make a video about LiveStore. And the date. Note how even though the date is represented in the database as a number, we're transforming it to and from an actual JavaScript date object, thanks to the use of effect schema under the hood. When we trigger any commits, they're entirely synchronous. We don't need to await this call. And if we want to, we can actually have multiple events within a simple commit call. So let's make a second to do. Indulge the side quest of making a Drizzle QueryBuilder adapter for LiveStore. And now let's query the store. Tables.todos. This will go ahead and place inside of the to-dos variable. Note that this is strongly typed. We have our list of to-dos. Also note that we're not awaiting this because this is entirely synchronous. This is really nice. And finally, let's log it out. We're now going to open the console and run the example. And we see the materialized rows. Let's go back to our query and see if we can narrow it down with a where. Here, we're going to say where the ID is equal to 1. We can get rid of these commits because it's persisted in the file system. So we have all those events and we have the current database state. They're right here. Maybe I should actually ignore this. And what this also means is that if we ever want to clear the state and start fresh, we can just delete this directory. We don't have to worry about restarting any kind of a Docker process or anything like that. And because the database is the result of event sourcing, you just add new events as you see fit, create the necessary materializer arms in order to materialize those events into the latest state. And then you just emit the new events. Now that we've commented out this commit, let's go ahead and run it once more. This time we should only see the one entry that we've selected. Great. This can throw if there are no items. So an alternative way to approach this is to specify the fallback and fallback to undefined. Line 102, we're going to change this to do, or I guess a better description would be maybe to do, given that this can be undefined. You see that now the undefined type is reflected in what store.query gets back. And here we're going to log out maybe to do. And just like before, it works. So upon running this, we're getting back the to do that we've selected. Let's maybe alter the completion state of it by running store.commit and specifying events.to-do completed, wherein we pass in the ID of 1 and the new date. And now we see the completed is true. If we were to change this to uncompleted and run it again, it's now set back to false. So we've tested out the core events and they appear to work. Let's comment out that commit. And let's think about the new experience that we want to replace this with. We'll comment this out as well. Down here, we'll say const maybe to do equals. And I think we should implement a query function that will take in the store and then it'll take in the builder. So this gives you a query builder. And then you'll use that query builder the same way that you would your Drizzle DB. So qb.select from to-dos .where eq to-dos.id 1. Now, eq is going to come from Drizzle ORM, so we should install that package. Now we should be able to add the import. And we're also going to need the to-dos table in the Drizzle format. So let's think about how we can take the tables, so a record, and turn it into a record of Drizzle tables. I think that a desirable experience would be to say Drizzle tables equals to Drizzle tables and pass in tables, the LiveStore versions. And then Drizzle tables will be a map type. So we're going to define a toDrizzleTables function as well as a query function. And so from here, we'll be able to extract to-dos. And this value will be a Drizzle table. So the first thing that we're going to need to do is implement this toDrizzleTables function. And once we have that, we'll create a query function, which is responsible for actually interacting with the LiveStore using the query that we build in this closure. Let's go over to LiveStore Drizzle, and here we'll create our index.ts. Let's also create a toDrizzleTables and a query.ts file. From index, we can export star from toDrizzleTables and also from query. In the toDrizzleTables file, let's mock out our toDrizzleTables function. Export const toDrizzleTables equals, and this should be generic. TA, I kind of like this. It's for table all. extends record string. And then here we're going to need the widest possible type for the LiveStore SQLite table definitions. If we import state from LiveStore, I believe this has a SQLite table def dot any, and this is the widest version of a table definition. Now we can say tables TA, and then we're going to want to map this TA into the Drizzle equivalent. So now the return type will be an anonymous map type, okay, in key of TA. And here we're going to need to use some kind of utility to transform one of these table defs into the Drizzle equivalent. So maybe we'll call this to Drizzle table, and this can take in TA. Okay. If we look at the table def type, we'll see that it has this SQLite def field on it. And this SQLite def field is what actually contains the columns. And the columns are what contain the column definitions. And this is the information that we need in order to map to the Drizzle column type. So instead of providing the entire table def, we can provide the SQLite def. And the SQLite def is this type that is hopefully accessible because we're going to want to create a to Drizzle table type wherein T extends SQLite def. I don't actually see this anywhere, so we might need to do a little bit of manual typing here. Type LiveStore table equals SQLite DSL dot table definition string SQLite DSL dot columns. And this should be a sufficient replacement. Now we need to figure out what we need to map that type into. So let's take a look at what the QueryBuilder actually gives us. Import from Drizzle or / SQLite core. And here we'll say SQLite table and QueryBuilder. Next, let's mock out what our to-dos would be if we were using Drizzle. I'm going to paste here our LiveStore equivalent just so that we're able to easily look down here. We're going to say const Drizzle to-dos table equals SQLite table to-dos. ID is an integer. Dot primary key. Text is text. Dot default. Dot not null. So this is one interesting distinction. In LiveStore, this is not null by default, whereas when using Drizzle, we have to explicitly specify not null. And I think this should give us a pretty good idea of the shape. It looks like there's this outer wrapping SQLite table with columns. So we want to provide this here as well. And then this accepts some kind of an object. Let's see if we can auto import it. And it looks like we can. If we take a look at the type, see it has this table config and a table config base. So this has name, schema, columns, and dialect. So we're going to want to specify all of those. Some of what we just copied, tcolumn, appears to be one of the type parameters. My guess is that this is going to be our mapped type, wherein we map our LiveStore table columns into the Drizzle equivalent. For name, we should be able to access that from the LiveStore table. For schema, I think we can just set this to undefined, but let's leave a note to confirm. Within dialect, this is going to be SQLite, and then here is where the magic is going to happen. So this is going to be a map type wherein we iterate over all of the keys of columns. So let's say T of columns K extends infer column. And let's add an extends SQLite DSL dot column definition. Any. This is just going to solve some inference errors down the line in cases where the TypeScript compiler isn't able to infer that columns is in fact a column definition. And this should always match. So we'll have our mapped value here, which we'll get to in a moment. It's never not going to match. And here we're going to need the Drizzle column type. Based on what we see below, it appears to be a SQLite column type. And why don't we just copy this entire value here and paste it in place here? We also are going to need to bring this SQLite column into scope. And now we can go through all of these properties and ensure that they're extracted from the LiveStore column type. We'll start with the name, which is going to be the given key. But changing that, we see we have an error. And the reason is because right here, this key of, even if it knows that T of columns has a string index signature, this key of check is widened. What we can do to circumvent that is extract string. Next, for the table name, we can do the same thing as above, where we just pass in T name. For column data type, I don't know if this is super important for the query building typing experience. For now, I think we can actually just leave this as the widest version of itself, which is column data type from Drizzle. So that could be any of these types. For the column type here, we're going to specify column and then pass in column type, which is a field column type, which can be one of these four. For data, this is where we actually want the JavaScript representation of the type. Any given column has a schema attached to it, so we're going to want to extract the schema type using effect schema. So we should be able to say schema.schema.type. Driver param, if I'm not mistaken, is going to be the type retrieved from the SQL database before decoded into the output type. So we should be able to access this with schema.schema.encoded and pass in column of schema. For not null, we can say column of nullable extends false. If so, then true, otherwise false. For has default, we're going to need to bring in the option namespace from effect. And this will be column default extends option.sum true, otherwise false. For is primary key, we can get away with column primary key. For auto increment, this isn't represented in LiveStore, so let's just say Boolean to be the widest type. And for has runtime default, I'm pretty sure we can just reuse this expression here. Enum values aren't yet part of the LiveStore table building experience, so we can leave this as undefined. With base column, I'm not sure what this is, but I actually think we can just delete it. Same thing with identity and generated. And that should give us our mapped types. Over here, let's row 0, we'll implement this later. Now, if we go back to our to-dos example, let's import from LiveStore Drizzle. We'll bring in 2 Drizzle tables. And let's see if we're getting back some of the things we would expect on the Drizzle table equivalent. First off, it should have an ID, which it does. And then we see a SQLite column wherein it has the table name, the column type, data type, the driver param, the fact that it's not null, the fact that there's no default, the fact that it is a primary key, and then auto increment is set to Boolean. Why don't we actually just disable that since LiveStore tables don't yet have auto increment? We'll go back to Drizzle tables, scroll down and set this to false. Also, let's get rid of this C spell error. We can go down here and comment out some of these mock tables that helped us figure out the types that we were working with. And let's go back to deduce. And the next thing that we're going to want to stub out is the query function signature. So we'll go to the query file and we will export const query equals. And the first parameter should be the LiveStore, which will come from LiveStore. And store has these two type params. Why don't we just set these to any? And then we're going to want to pass in the build function. So this will take in the QB, a query builder from Drizzle SQLite core. And this should return some type that we're going to need to infer. So build, we'll go here, and this is going to extend the end result of building the query. So let's take a look at QueryBuilder. And it seems that this SQLite select builder is the end result of building the query. We'll go here and see if we're able to access this type. And this type does have quite a few type params. So maybe there's some version of it that already has all of the type args applied, and it seems there is. So this passes in all of the type arguments as any. So we can get rid of this and use this as the constraint on build. And finally, we're going to want to return the build. And here we'll access this inner value, which should contain the result type. And once again, we'll throw 0 and implement this later. Let's go back to our to-dos example. And we're getting an error here. Let's bring this into scope. And it's yelling at us. Let's come over here and add braces to this. We'll capture this as built and return built. And what is this? So it appears Drizzle's QueryBuilder is using omit as part of their chaining API's mechanism for tracking what stages the builder has already undergone. It's not super obvious how to represent any builder type at any stage. So I think what we should maybe do is go back to our query. And up here, we can pick the values that we ultimately need from it, which are the underscore, as well as later, we're going to make use of the toSQL method. And now if we go back to our to-dos, there's no longer a type error. And if we hover over maybe to do, we see that it's a list of the expected type. Let's also go ahead and just return this anonymous like we were before. Now, in order to get the runtime of this integration working, let's implement 2 Drizzle tables. Here, we should be able to return record just from effect.map. So we're going to map over the tables record. And for every definition, we're going to make sure that there is a SQLite def. If there isn't a SQLite def, then we can assume that it's a document and not a table definition. So if there's a SQLite def, we're going to want to transform it, and maybe we'll name this function toDrizzle table with def.SQLite def. Otherwise, undefined. And we'll as never, because the compiler can't know that we've stayed true to this map type. Now let's implement our toDrizzle table function. The def that we pass in is a LiveStore table, and it's going to return a SQLite table wherein we pass the name as the first argument, and then we're going to use record.map again, this time mapping over all of the columns of the definition. Each column is going to need to first be turned into a Drizzle type, and then we're going to have to apply any stages of the builder, such as marking it as a primary key or not null, or adding a default value. So the first step of this is going to be to get the base type, and the base type needs to account for the schema that underlies that LiveStore column. So I think the first step is going to be to have this like toDrizzle type method wherein we pass the column. If we look at this call, we see it's a SQLite column definition. And now const toDrizzle type equals. And here's where we're going to want to create the actual Drizzle type. In order to create the type, we're going to need to extract the column type and the schema from the LiveStore definition. Next, we're going to return a custom type, wherein the data type is a function that just returns the column type. toDriver can take in the schema.encode sync of the schema, and from driver can take in the schema.decode sync also of schema. And the last thing that we're going to want to do is actually call this, because the custom type gives us a factory for that type, but it doesn't actually give us an instance of the type, and we want an instance. If we come up here, maybe the next thing that we should do is have a pipe, and that type will be the first stage in the pipe. The second stage can take in the given type. This should be a Boolean, and if it is the primary key, then we'll call primary key. Otherwise, we're going to want to see if the column is not nullable, and if it's not nullable, then we're going to apply not null. Otherwise, we just return the type as is. And finally, we're going to check if there is a default. And if there is, then we're going to set the default equal to call.default.value. Otherwise, we leave it as is. And that should do the trick as far as the runtime functionality of toDrizzle tables. Now let's go to query and let's get this part of it working. We'll go down to the implementation, and we're going to say built equals build, and here pass in a new QueryBuilder. We're going to pass in a new SQLite sync dialect. And we're also going to get rid of this type right here, since we're actually using the constructor at runtime. Once we have the query, let's call the toSQL method, from which we'll be able to extract the actual SQL string, as well as the parameters that we're going to bind to the SQL string when we execute it. Let's execute the query with store.query. Here we pass in the query as SQL and the bind values as params. We're getting a type error here, but I don't think this type error is correct. So let's as never to satisfy the checker. And finally, we'll capture the rows from the query. This is not the correct type for rows. I'm not sure why store.query isn't giving us an array. So we're just going to as array unknown. And finally, we're going to want to map over every row and ensure that the values contained within them have been transformed from the driver value into the decoded JavaScript value. And one thing that's pretty cool is that build is going to contain the selected fields. And the selected fields, although it's not typed here, actually have a map from driver value function on them. So it's going to be very easy to do this mapping. We simply return rows.map, and for each row, we're going to record.map. Again, we'll need to bring a record in from effect. built._.selected fields. And for every column, to make our lives just a little bit easier, can say const call equals call as SQLite custom column of any. And we'll return call.map from driver value, the given row and key. If we go back to our to-dos now, let's delete this value right here. Let's also console log maybe to do. And actually this is a list, so let's just call this rows. And let's ensure that we're in the root of our project. We'll run build. And now let's run our example. And now it's giving us exactly the data we queried for, and it's performing the transformation of the date integer into a JavaScript date, as well as the integer representation of a Boolean into a JavaScript Boolean. And that's probably a pretty good stopping place for now. I must say, I'm really enjoying LiveStore. I'm enjoying the separation of concerns, and I'm really keen on continuing to mess around with it. Also, I'm going to try to get feedback on the integration, and perhaps if it's worthwhile, we'll push it forward and get it published. And thank you so much for watching.